Hi, I'm Betina Hocson, and today we'll be doing proving. Our topic for today's proving are all about perpendicular bisectors. So first, let's see the figure. So here we have our given statements. So it says that AB over 2 is equal to AC. Ray CD intersects segment AB at point C. And that angle ACD is a right angle. So what we're trying to prove is that ray CD is a perpendicular bisector. So first, let's define what a perpendicular bisector is. So from the word bisector, bisect means to cut something into two equal parts. So in this figure, you can see that AB is a bisector of PQ. For it to be a perpendicular bisector, it must cross it at a 90-degree angle, at the same time cutting the segment into two equal parts. Now that we've defined what we're trying to prove, we can analyze the figure more carefully. Again, for something to be a perpendicular bisector, it must satisfy two conditions. One, it has to pass through a midpoint, and two, it has to pass through the midpoint at a 90-degree angle. In the given statements in the figure, it says that angle ACD is already a right angle, so that satisfies one of the conditions. What we need to prove is that point C, where it intersects, is the midpoint of the figure. We can actually already tell from the given statements that there's an indication that C is the midpoint. That is through AB over 2 is equal to AC. Now that we have come up with something to work with, we can start our proof. We will be using the two-column proof. In the first column are our statements, and in the second column, the reason behind the statement we just put. So let's start. The first number will always be the given. So again, AB over 2 is equal to AC. Ray CD intersects AB at point C, and that angle ACD is a right angle. So the reason behind that is simply the given. Now we can work with AB over 2 is equal to AC, since that's what we strategized in the first place. Since AB divided by 2 is equal to AC, it means that AB is equal to AC plus CB. We use the segment addition postulate, which states that if a point B lies on the segment AC, then AB plus BC is equal to AC. Continuing, since we now have another value for AB, we can plug it into the given equation of AB over 2 is equal to AC. This will make it AC plus CB over 2 is equal to AC. Here, we simply use substitution, which is replacing a term with another one of equal value. So the next step will be taking out the denominator. So this is a way of simplifying it as well. So we'll be using the multiplication property of equality by multiplying 2 to both sides of the equation in order to take out the denominator on the left-hand side. So after this, we will be left with AC plus CB is equal to 2AC. So through expansion, we can make it AC plus CB is equal to AC plus AC. Since you might have noticed that AC is common on both sides, we can use the addition property of equality to subtract AC from each side of the equation. This will leave us with CB is equal to AC. So going back to the figure, since we just declared that CB is equal to AC, we can say that C is the midpoint of AB by the definition of a midpoint. Conclusion: our last two statements for the proof would be C is the midpoint of AB by the definition, and then the final one would be CD is a perpendicular bisector by the definition of a perpendicular bisector that it passes through the midpoint and forming a 90-degree angle.